Hello and welcome also from my side. Today I would like to give you a little introduction into how to automate the fraud management process, or how to use robotic processing to make your process much more efficient. Before we dig into details, I would like to give or have a first look at the challenges when we look at fraud management. So today there's always a huge amount of transactions and huge data volumes involved when we look at fraud patterns and potential fraud cases. Another topic is also the complexity of patterns. The business processes are more and more complex. There's a heterogeneous system landscape. So we have systems in the cloud, we have on-premise SAP systems, we have non-SAP systems. So the process and the involved systems is really complex, and that needs to be analyzed when we look at two potential fraud patterns. You have a lot of customers that are still doing quite some work when it comes to fraud analysis manually. And as you can imagine, it is very time consuming to go into the systems, check the tables. It's not, even if it's different systems with different data structure, it's required to link the data, do an aggregation of the data, sometimes even copying everything into Excel and then doing the comparison in Excel. As you can imagine, this is not the most efficient way. Then we also have the impact on business. So when we investigate, we need to talk to the business users. Sometimes it's even required to stop the ongoing process, which lead to complications if it's a lot of false positives that we have, and with the business not so much agreeing on stopping the process, even if there's only a potential fraud case. And that comes to the next topic. We have many false positives. So there's a lot of data involved into checking and analyzing fraud cases, but there might be a lot of false positives. So only a small portion of the actual cases investigated turn out to be really true fraud. And that's where we would like to have a system to support us to make this more efficient. Before we look into the details, I just want to do a quick recap. Maybe you've seen one of the previous sessions. There's different types of robotic processing and automation. So one type could be robotic execution of human actions. So if you write scripts. Another type is automation of data preparation, where we aggregate data before and give like just a compromised version for the user review. We have automated issue detection, where only in case of specific alerts or specific behavior there's issues coming up, and then the user does not need to analyze the data himself, but only in case of issues need to investigate. Automation of decision proposal. This could be that there's probability rating, for example, from the system saying this is very likely that this is a fraud case, or the likelihood is only 50%. So there could be some probabilities behind it, or even in tax compliance, for example, there's some task that could be even suggested or assigned to cases, so that these are the next steps that needs to be taken. Management of bots. For sure, if you automate things, then and let the machine do the work, you also need to check that this machine is doing the correct work and that the processing is running correctly. So you need some kind of monitoring management. And in the BAS case that we will see later, it's checking that the parameters are still correct, that the efficiency is all right. So there's some steps that need to be taken care of. So let's have a look at business integrity screening. SAP Business Integrity Screening, or previously called fraud management as well, is a nice tool that you can use to screen a huge amount of data. So we have the HANA database underneath it, which has a lot of capabilities to work with huge amount of data. We can check complex patterns across system landscapes. So as mentioned before, if there's a heterogeneous system landscape, we can include cloud systems, we can include non-SAP systems to sync the data into the BIS, and then even do cross-checks between different systems. And also even within one system, the setup could be really complex for accounting, for example, and there we have a lot of options with BIS. Good thing is also that the detection can be integrated into the business process. So, for example, with S/4HANA, there's a standard integration with the payment engine. So automatically when the payment is started, then there is a cross-check in BIS where we check if the payment is going to a high-risk country or if there might be potential sanctions. So there is some standard integration potential. But it's also possible to have your own integration. If you build your own screening methods, then you can build a little web service and then call directly from the business process, call the BIS, check if there's critical topics, and then send the results back to the system and stop the process if there's something potential fraudulent going on. Also for master data governance, there's a standard integration to the business process where you can integrate BIS for screening of business partners that are checked against, for example, Dow Jones or other sanction lists. Then when we do the automation, then we can also do real-time calibration to optimize the setup. So that is when I mentioned the monitoring of bots. We need to make sure that the settings and parameters are still okay, and we can fine-tune the parameters. Predictive analytics is another nice topic that we will see in the demo later. So it's possible to use predictive analytics to identify even more other parameters that are relevant for fraud identification. So there's a predictive model generated and that can be used then directly for the processing, or we use the information for the parameters to enhance our setup in the detection strategy. So before we start with the example, you can imagine you're now manually doing your work. You know, for example, that if there are changes to bank data very close to payment, this could be a critical case. So someone is going to a system, changing the bank of a vendor, and then when the payment is running, the payment is going to this account and then changing back the data afterwards. So this could be a known pattern. And then we have unknown patterns. This is something where we can look into with predictive analytics, where we have, for example, found a few fraud cases and then try to analyze what are indicators, where indicators in the data, how can we identify these cases. When we look at the process, we have in business integrity screening, I want to make it as easy as possible. So we have a detection part. This is the process that was previously manual, where you look into the tables and look for the bank data and maybe also look for the payment data, then try to cross-reference. This is what the system can do automatically in this detection part. And we can provide them with parameters, and then the system is deciding this is critical or this is not critical. And if it's critical, there's an alert created that is on the right side. This alert needs to be investigated. So for our case, the system is checking if there's outgoing payments, then checking if the bank data was changed recently or within a short time frame. You could, for example, provide a parameter, the time difference between payment and bank change. And we could also provide a parameter for the amount, if the amount is in a specific range, because we can imagine it could be that very high values are interesting, so that you book 5 million and then go to the Caymans, or that you do rather small amounts, and so that no one notices that these amounts are missing somewhere. Still required is manual interaction. So Once these parameters thresholds are executed or reached, then there's an alert created, but then still human needs to investigate the alert. So the good thing is that previously you spent a lot of time in the detection part, that you can now spend more time on the investigation part. And also BIS is supporting with additional data that you have and information. You have navigation targets, you can jump into the target systems. You have network analysis supporting you to investigate this alert and make also this investigation more efficient. Still, the goal is to generate less false positives, while we still find the true fraud cases. With that, I would like to go into the demo, the next part. So sum up, we have the manual process in the beginning, and now we have our system in place that is automating the detection, and we want to try to increase our efficiency of this automation a little bit more. So we have, first of all, we have the option to increase it manually. We change the parameters of the detection strategy and then simulate the results on our historical data. And this is the first part of the demo. And then we would like to increase the efficiency with predictive analytics. And in the end, as the last step of the demo, we check or give you a little overview of this predictive detection method, what it looks like, what are relevant variables, what did we learn from this exercise. With that, I go into the system. So this is a BIS system. Maybe before we go into the details of the calibration, let's have a quick look what an alert looks like. So that some of you did not see the system before, that you can imagine what's behind it. So we see for this example, for this analyze of bank data example, we have 35,000 alerts in the system. They are already classified. So back in time, someone was working on it, on the investigation. An alert looks like this. You have some general information, a risk value, risk factor. You also have on the detection part, you have the details of the detection strategy. You have also, when you go into detection methods, you have the details, what parameters were used, what amounts, and so on. So you have a lot of detail here. On the documentation, it's possible to upload document, create notes, create tasks. This one was not documented so good, but it was a false positive, maybe a quick look and someone had just closed it. You have activity log where you can see what happened, who did what, at what time. And important on the decision, this is where you can see that the finding was a false alarm. And in the summary, you can see that bank updates were authorized or there was no approval required, so no fraudulent behavior. So this was a case where payment was okay and there was nothing suspicious found. So it's also possible to create navigation targets. As mentioned, the network analysis was not enabled for this one, but there's other scenarios where we have the network analysis if you're interested in afterwards. So this is how an alert looks like. So if we go to the detection strategies, this is where we go into now because we want to optimize our detection strategy. So the detection strategy is running, for example, on a daily basis, checking if there is some changes close to these payments. And now we want to see and optimize to reduce the number of false positives. So the strategy has some parameters, and yeah, let's go to the calibration. That's the easiest way to see it here. So I need to change the time frame. So first of all, what you can see that we have our data set. Actually, we are 4% efficient. So we have more than 1,000 confirmed fraud cases in this time frame, and we have almost 34,000 false positives. So quite a lot of false positives that take time to investigate. And this is what we try, that we now want to reduce this number of false positives while we keep the same number of confirmed fraud cases. We have some options. This is the detection method used at the moment. So bank changes close to payment, where we have some parameters. So we have as a parameter the days between payment and bank change. It's set to 31 days, so that's quite a long time frame. So that's probably where we start and reduce it a little bit. And we have lower and upper thresholds to play around a little bit with the amount ranges that we have here. So we could, for example, now say, let's reduce the number of days to 10 and then start the simulation. Now the system is checking what would, on the historical data, what is with these settings, how would the decision be, or how many alerts would be generated with these settings based on this historical data where we already had decisions. So you can see that we have increased the efficiency to 6%. We have still the same number of confirmed fraud cases, and we have 12,000 false positives less. As you can imagine, 12,000 alerts to investigate, that's already quite a lot. This would already mean some work less for the investigators. So we can also reduce further. So if we reduce it to 1, then we see that we already start to lose confirmed fraud cases. So we are back to efficiency of 4% because we only find half of the confirmed fraud cases. So this would probably be not the best setup. So we set it back to 10 and maybe check if the value range is more likely to be low. So we check between 0 and 12, 0 and 2,000 euros. If we start simulation now, we see that we have 7% efficiency. So this looks already better than in the beginning. What's also nice is you have the simulation results here, where you can have a look at the results in some graphs. So you can see here false positives before and after. Confirmed cases are still almost the same. You can also show the numbers in tables. So we see that we have 8 confirmed fraud cases that we do not find with this setup. And sometimes also interesting when you look at the risk values, because if it's just entries or documents with €1, then we might not consider them. But we see that these 8 cases had 26,000 euros behind it. What's also nice, you can click on this missed cases. You see the list of cases. You could even navigate and jump to this actual alert. So you can directly navigate from the simulation results into the historical fraud case that we had here. Okay. Now we have played around a little bit with the parameters that we can manually optimize. So we already saw that it's possible to optimize the efficiency. Now we want to use the predictive analytics detection method. For that, I put the weighting factor to 0 and this one to 50, so that the simulation will take this new predictive detection method. We have also one parameter that is the confusion matrix threshold. So this sounds really strange and it's hard to explain, but you can imagine it as a parameter to find the right ratio between missing confirmed fraud cases and reducing the number of false positives. So I think I have one slide maybe that I can show. So imagine you have a set of data, and the predictive detection method is building a score for this data. So every combination of document, company code, and fiscal year gets a score. And with the threshold, every score that is above this threshold will be an alert will be created. So you can see if we have the threshold at 0.2, we have all these. So 4 cases, 4 fraud cases that are found, and 6 non-fraud cases. If we go to the other example, threshold of 0.2, we have above it, we have 3 non-fraud cases and 3 fraud cases. So it's basically setting the threshold to find the right combination of missing some fraud cases and reducing the number of no fraud cases. Okay, so if we start now with this standard factor, or with this factor 0.1, we can start the simulation. And see that we already have an efficiency that is higher than before. We are at 9%. We see that we lose some of confirmed fraud cases, but when we look at the details for the risk values, we can see that we have more than before. So here we had -8 found fraud cases. Now we have -24, but there are less value. So the value was 26,000 before, and now it's 12,000. So as mentioned, it's also good to look at the euro numbers behind it, not only the numbers of alerts. Yeah, we can now increase further. So if we set it to 0.3, we will lose some more confirmed fraud cases, but we will also get more efficient. Yeah, as you can see, we have now 19% efficiency. So we only have 5,000 false positives compared to this 34,000 false positives in the beginning. I would say this would be saving quite a lot of work in the department. You can increase more and more, but at some point you will start losing efficiency, or you will have only half of the confirmed fraud cases found. So yeah, now we find only 900 of this 1,200. So it's yeah, this is a parameter where you can set up and define for yourself how much confirmed fraud cases are you willing to lose to reduce the number of false positives. So that is what the parameter is for. And just as a side remark, you see 48% efficiency. So the efficiency is calculated from the ratio from the number of confirmed fraud cases found, divided by the number of the total number of fraud cases that are available, that are confirmed, plus the number of false positives. So it's basically, in this case, 904 divided by 1,885 or something like that. Yeah, now that we have seen how we can use the calibration and also show that the predictive analytics is a good way of increasing the efficiency. So let's have a look at the predictive analytics detection method. So we go to manage detection methods, then filter for predictive detection method. And we have this predictive analytics bank and change payment data method. So what you can see here now is we have the data set. This historical data was some 35,000 entries. There's a model generated from it where you can see the quality of the model with the predictive power and predictive confidence. The closer it is to 1, the better. So this seems to be quite good. We had 3 years of training data in this case. And from the results of the key influencers, we can see that we have identified as the most influence has the changes close to payment. So in the manual one we had, this is the number of days that is between the payment and the bank change. And also the amount is quite relevant. So these are the two that we had identified as an expert. And now we can see that there's other parameters relevant, like the transaction code, the T code entered or used to enter the data. So also multiple updates by the same user. So this is when a user changed it forth and back again. So and also, excuse me, document type is relevant. So you can see that we identified manually the two main factors, but there's other factors that are quite relevant as well. And that's why this detection method, this predictive detection method, can increase the efficiency quite high because all or a lot of data is taken into account for the analysis. If you use these predictive detection methods, you can also train the model again and again. So maybe, for example, after 3 or 4 months or half a year, you see a change in your data. So then you can train the model again. You can even provide some more data that you might feel that is relevant. And yeah, based on that data, run the analyze again and see if there maybe over time are coming other factors into the game that are now relevant. Yeah, and with that, I'm done with the demo part. So I go back to the slides and we have a look at the key points. So the key points from today is that automation can make life much easier. We saw, or we discussed in the beginning, that users spending time to look into the tables and aggregating the data. This can also be done by the system, and the user can spend more valuable time on the investigation of the cases. Also, the automation can cover a broader range of data, include more different data sets or fields that are investigated that we saw during the predictive analytics demo. And yeah, instead of doing spot checks, EIS can cover basically all of the data. Yeah, and we saw that predictive analytics can help to increase efficiency on a quite high level. When we saw during the demo in the beginning 4%, after that we can set it up to 19% or something like that, with where we still get almost all of the proven fraud cases and reduce the number of false positives in a really big way. And with that, I thank you very much for listening.